Good morning everyone. Today we are going to learn unit number 2, computer hardware and peripheral. In this lecture we will study the motherboard, port and buses, which are the key hardware part of a computer. This component connect all internal and external devices and allow to smooth communication between them. Now the next one is the important topics, introduction to motherboard, port and buses. Here we cover. The syllabus shows we will learn how these components are connected, how they are work, their roles in the computer operation. Now the next one is the introduction to motherboard, port and bus. The motherboard is also called as the system board. It is the main printed board inside the computer that connects major component like CPU, memory and storage. The diagram that shows the motherboard layout, here you can see the various ports such as slot, socket, chips, and they are connected to all components together. Now the next one is the parts of motherboard. The motherboard contains the several important parts like expansion slot, CPU holder, memory holder, then power supply connector, north bridge, south bridge chipset, CMOS chip, CMOS battery and SATA controller. Each part has unit function to support the system working. The diagram shows the image, diagram that labels the image of motherboard so that you can easily identify each part. The first component is called the expansion slot. Expansion slots are the long thin connector on the motherboard. They are used to attach additional card like sound card, network card or the display card to improve the computer performance when the card are inserted that connect directly to the motherboard system. The diagram shows the long white or the black lines on the board represent the expansion slot. Now the next one is CPU holder. CPU holder is also known as the processor socket, where the CPUs are fixed. It connects to the processor to the motherboard and allowed to communicate with all components. The CPU is often called as the brain of the computer. In the diagram, the square shape areas in the center, the motherboard is called as the CPU holder. Now the next component is the memory holder. Memory holder is also called as a RAM holder, where the memory modules are inserted. Most of the motherboard have 2 to 4 slot for the RAM. This slot is determine the types of RAM that can be used, such as DDR3, DDR4 or the DDR5. The diagram shows long slot near the CPU socket called as a memory holder. Now the next component is called as a power supply controller. Power supply connector is the portion of the motherboard where the power cable from the PCU is connected. This supplies the electric power to all part of computer. The older motherboard used AT connector while the modern one is used ATX connector. In the diagram you can see the white connector where we attach the power cable. Now the next one is north bridge and the south bridge. So north bridge and the south bridge, they are the two important chip on the motherboard. Now north bridge that handles the fast communication between the CPU, memory and graphics card, where the south bridge manage the slower device like USB, hard drives and the network interface. The diagram shows both the chips in middle area of the motherboard that connect the various components to the data bus. Now the next component is the CMOS and BIOS chips, BIOS chips. CMOS and BIOS chips that contain the system basic input-output software. It stores the instruction that helps to computer startup and to check the hardware before the operating system load. The small black chip is shown in the diagram called as the BIOS and the CMOS chips. Now the next one is CMOS battery. CMOS battery that helps the system remember to date, time and BIOS setting when the power is off. It is small round silver coin battery that attached to the motherboard. The diagram shows the coin shaped battery clearly on one side of the board. And the last one is SATA controller. SATA controller that connects the storage devices like hard drives and SSD to the motherboard. It allows to fast data transfer than older ATA connection. In the diagram, you can see the small L-shaped connector on the motherboard called as the SATA port. Now the next one is the ports. A computer port is a physical connection point or the interface that used to connect external peripheral device such as printer, keyboard, mouse or monitor. There are mainly two types of port, parallel port and the serial port, along with some other type PS2 and SCSM. These ports make easy for the computer to communicate to the external device. The diagram that shows the different types of ports that present at the back of the CPU cabinet. Diagram shows the different types of a port with the example of PS2 keyboard connector, serial communication port, line jack, gain, then RJ45 for the network port. Each port has a specific function. For example, PS2 is for the keyboard, serial port is a data transfer, RJ45 is the internet connection. The diagram that help us to identify this port visually. Now the first port is the parallel port. So the parallel port is used to transfer the data between the computer and external device such as the printer using the 25 and the 36 pin connector. In the parallel communication, the multiple bit data transfer at the same time, which makes to faster than the serial communication. The IEEE 1284 standard that allow to port to send and receive the data, making it bidirectional. The diagram shows the parallel connector with the many pin are arranged in the parallelly. Now the speed of the parallel port is ranged between the 50 kb to 150, 50 kb to 150 kb, and in advanced mode like the EPP. EPP means the enhanced parallel port or the ECP, extended capability port. It can be reached up to the 2 Mbps. These modes allow to 60 bit or the 32 bit data transfer that improving the communication between the printers and the scanner. The diagram shows the data line that is used by the parallel port. So this is the pin configuration of the parallel port. Now the next one is the serial port. So serial port is a transfer the data one bit at a time. Unlike the parallel port, it was commonly used to connect the devices like modems or the mouse. Over the time, serial port have the replaced by the modern connectors such as the USB and the HDMI. Still, the concept of serial communication to be continued the inside the modern computer in the technology like SATA. The diagram shows the DB9 serial connector that used for the older communication device. So this is the diagram shows the serial port DB9 connector pin out. So here the each pin has the specific function. For example, pin 2 is receive data, pin 3 is transmit data, pin 5 is for the ground. Okay. So this diagram is all the 9 labels are clearly shows. So today serial port is mostly found in industry system or the microcontroller programming. The modern computer no longer have the external DB connector, but the same data transfer the method is still usually is the SATA for the hard drives and the optical drives. So in the diagram that shows the DB9 old DB9 connector and the new SATA cable connector. Now the next one is PS2. personal system to port. So the personal system to port was introduced by IBM in 1987 for connecting the keyboard and mouse. It is replaced by the older serial connection for this device. PS2 provide the reliable connection and were the standard on the PC for the many years. So diagram that shows the round 6 pins PS2 connector typically color by the purple color for the keyboard and the green for the mouse. Now the next one is PS2 ports. We can see the more information about the PS2 ports in this slide. These ports are where usually for connecting the both keyboards and the mouse to the computer. Originally, both the connectors were the same color, but later the IBM is assigned the purple for the keyboard and the green for the mouse for the avoid the confusion. Each PS2 connector has 6 pins that carry the data, clock signal, power and ground. The diagram in the diagram shows that mean DIN connector with its pin numbers and the color code clearly marked. So PS2 is now mostly replaced by the USB ports. So they are still seen in the same older system. So this is a configuration of the PS2 port. So the pin 1 for the data, pin 3 for the ground, pin 4 for the voltage, pin 5 for the clock, and the remaining pins are not connected. So these are the signals that allow to the keyboard and mouse to communicate serially with the computers. Now the next one is USB port. So the USB, what is the long form of USB? Universal Serial Bus Port. So it is a most commonly used the connection point in the modern computer. It was designed mid 1990s to replace the older port like serial, parallel and the PS2. A standard USB port has the 4 pins, 2 for the power and 2 for the data transfer. The diagram shows the different USB connectors such as the Type A, Type B, Mini A and Mini B. So in 1960, the first USB 1.0 standard was released, supporting the speed with 1.5 Mbps and 12 Mbps. Later, USB 2 was introduced 2000 with the 480 Mbps speed, and in 2008, USB 3.0, the speed is 5 Gbps, about 10 times faster than USB 2.0. The diagram shows the different USB version and show the different connectors. We can also see how the USB ports are used various devices like printer, storage device and the mobile charger. Now the next one is Firewire port. So Firewire port is also known as the IEEE 1394 or iLink, was developed by the Apple in 1990 for the high-speed data transformation. It was commonly used for the digital videos camera and the external hard drives and audio equipment. Firewire could transfer the data much faster than the USB 1.0 and was mainly used in the Apple computer. The diagram shows the rectangle. Firewall port. It is the symbol found in older Mac devices that is supports to the different operating system include the Windows, Mac OS, Linux and FreeBSD. So now what is the feature of Firewire? Firewire is supports to 400 to 800 Mbps and can connect the multiple devices chain without the hub. It also provides the power to connect a device which is similar to the USB. The diagram shows the different Firewire connectors, 4 pins and the 6 pins. Each is used for the different devices. Now the next one is Ethernet port. Ethernet port is used to connect a computer to the network or the internet through a cable. So it was introduced in 1980s and become standard by the 1985. Originally, the coaxial cable are used, but they are replaced by the twisted cable with the RJ45 connector. The diagram shows the Ethernet port and the cable plugs that is used to connect the routers as well as the switch. Now, the Ethernet port carries the 100 Mbps to 10 Mbps speed. High speed data is usually to transfer the network like CCTV, IP network or the cable company. But last case, high speed is only obtained between the switch and router in the most cases that receives only the 10 to 100 Mbps data. Now the next one is Ethernet cable distance and limitation. The maximum length of standard Ethernet cable between the device like switches, routers and the computer is 100 meter. Beyond this distance, the signal strength start to drop and causes the data loss. To extend the range, device like signal booster, repeater and the switches are used. The diagram shows the long network cable with the distance marking and the booster that place at the intervals. Now we move to the next important topic, buses. A bus is a communication pathway inside the computer. Basically, that is used to transfer the data, address and control signal between the component like CPU, memory and the input-output devices. The bus acts as a data highway that inside the computer system. The diagram shows the line that connecting the CPU, RAM and input-output device which is represent the different buses at the works. Now the next one is the function of buses. The main function of bus to enable the communication between the processor and the other part of computer. It carries the CPU to memory or output devices and bring the input from the external device to the CPU. The bus system that ensure the all part of the computer work together efficiently, which is shown in the figure. There are the different types of bus: data bus, address bus and the control bus. So here the data bus that carries the data that being processed, address bus that carries the memory address where the data should be read or written, and the last one is the control bus that carries the control signal like read and write instruction, which is shown in the diagram. So this is the diagram shows the system bus model. Here there are used three different buses: data bus, address bus and control bus. Now the first one is the data bus. So data bus is used to transfer the data between the CPU, memory and other devices. It is the bidirectional. Bidirectional means the data can be transferred from the both direction, means the CPU to other device and other device to CPU. The width of the database is 8-bit, 32-bit, 16-bit and the 64-bit. It determines how the data is transferred at a time called as the size of the database. Now the next one is address bus. Address bus that carries the memory's address of data that telling the CPU where the data is sent and receive the information. It is a unidirectional and the addresses travels only from the CPU to the memory or other device. The width of the address bus that determines how much memory to the system can access. For example, 16-bit address can access only the 64-bit of the memory, while 32-bit bus can address up to the 4 GB, which is as shown in the diagram. Now the next one is the control bus. So the control bus that carries the control signal from the CPU to other component. So this signal tells to system what operation to perform. For example, whether a read data from the memory or the write data to it. The control bus also carries the synchronization signal and the status flag. It also the bidirectional that ensure the proper coordination between the all hardware component, so which is shown in the diagram, the control line that connects to CPU with memory and the input output device that ensuring the smooth data flow. Now the next one is the bus operation. So they are the different categories of the bus, internal as well as the external. Internal bus connects to the CPU, register and the cache memory, and the external bus that connect to the CPU to external device, that is RAM, graphics card, IO controller. Internal bus that operates at the much higher speed than the external bus, which is shown in the diagram. Now the next one is, so now tell me what is the advantage of bus system. So bus system is simplify the computer to wiring and designing. It allows to all computer to share the common communication path that reducing the complexity. It also supports the easy expansion and the new devices can be added by using the same bus line. So here the bus can provide the flexibility, cost efficiency, then standardization across the different hardware component. So there are the many limitation of the bus system. So here, when there are the too many devices to share the same bus, data traffic can be increases, which can be slow down the performance. And another limitation is the bus contention, where the multiple devices try to use the same bus at a time. So also the number of devices can be increasing and maintaining the synchronization becomes more difficult. So these are the limitation of the bus system. So this slide is conclude our topics motherboard, ports and buses. So here we learn the parts of the motherboards. Then ports are the external connection. Then point for the input and output communication between the devices, while the buses are the internal data pathway that allow to CPU, memory and peripheral that work together. So understanding this concept that help us to know how the data is traveled from the both side, means the inside and the outside of the computer system. Thank you.